Welcome to an evening with Rob Pulham, who is the competition manager on the Guild technical team, and he's been building locomotive kits for several years. So it says here, and I'm sure everybody knows that. We've seen you at enough Guild events, Rob.
Yeah. Well, I suppose it depends on whether everybody's been to Guild events.
Yeah.
If they're non-members, not necessarily.
And
I apologise for the fact that you can't see the top half of my head, but it's unfortunately the fact that I've got no hair and the light's directly above me. And there's nothing I can do about it, unfortunately.
Now, my script here says that you've learned how to improve the models using lathes and milling machines, but I've edited that, and instead I am going to say that, and you will be demonstrating how you use machine tools for producing parts for your models. Is that a better
Yes, yeah,
description?
because there's a little bit about a mini pillar drill in there as well, so
Yeah.
it's not just about lathe and milling machine.
Anyway, so it's welcome to you, Rob. Thanks for joining us, and it's all yours.
Thank you. Well, hopefully everybody's had a look at the preview video, so they get a bit of a flavour of what we're all about. The first thing I'd like to say is that I'm not an engineer. I've had no formal training beyond a metalwork O level that I did in 1980. And in the intervening 38 years prior to getting a lathe, I'd done quite a bit of woodworking, to be fair. I've used a router table and things like that. But beyond using a pillar drill for woodworking, I've done nothing engineering wise. So all my learning has been pretty much since 2018. So anybody that hasn't got a lathe and would like to sort of start, hopefully this will tell you some of the sort of the pitfalls that I fell into and struggle to get out of, if you know what I mean. I'm just going to share my screen, and I'm basically going to talk around a load of slides as the best way to sort of share some of the things that I've been. Oh, it says host disabled participant screen sharing.
Right. Let me see if I can allow you to do that.
If you just make him a co-host, that should do, Dave.
Okay. Well, I'm going to make you co-host then, Rob.
Yeah, cool.
Now I have two co-hosts. You're hosting yourself.
Yeah, it still keeps telling me that. Oh no, there we go. I wonder if I can just make that full screen and can everybody see that full screen now? Or has it still got the little bits on the side?
It's almost full screen.
Yeah, there's a like a notes bit on the side of my screen here. So sorry, I've never done this via Zoom before. I've done it via.
Are they Zoom notes that are down the side of your screen?
Yeah, but I don't want the notes, if you know what I mean.
Well,
I'm just trying to work out how to turn them off.
There's a little. Is there a little cross up the panel? Get rid of them.
No. Oh, no notes. No. Anyway, right. Well, sorry, because I can't see what you can see. So get that thing on. So display settings.
Well, we can see the main picture, and then the slide presentation down down the left hand side.
Right.
We've got all those.
Yeah. Well, I don't really want that. I was just hoping to get the just the main slide in the middle. I present a view. That's better, isn't it?
Yep.
Yeah.
That's
right.
it. There we got it.
Let's go back. It. Yeah. Right. Back in 2018, I was at Lee Show And I'd previously made a decision, probably, I don't know, maybe 2012, 2013. I'd thought about buying a lathe, and then I'd sort of, at that time, I'd sort of had a brief look, and they were around about £600, the ones that I looked at. And I thought, well, I can buy an awful lot of castings for £600. So I decided against buying a lathe. Fast forward to 2018, and I was with a fellow guild member, David Halliwell, at Lee's show. And this lathe in the photograph, just as it is there, was for sale on the bring and buy for £150. So I thought, 150 quid, I'll have a go at that. So I bought it, but when I got it home, you'll notice that there's a vice on there, and that's because the milling post was actually assembled on the back and it was set up as a mill. And what I didn't realise in my complete naivety was that it was missing the tool post. Could I heckers like get a tool post in this country? I finally found one after sort of probably 6 weeks of searching in America, and it cost me $20. It cost me $50 to get it shipped over here. It's an absolute nightmare. So one of the things about this, and I'll just flip back to the other slide, is that people who are familiar with Unimats will know that they have a duty cycle. I had no idea about the duty cycle on these things, and I was busy having a go at turning a taper on a bit of bar. I wasn't really making anything. I would just try to refamiliarise with myself with things that I'd done back at school. And all of a sudden, the machine just stopped and it wouldn't start. And I thought, well, I could have blown it up. You know what I mean? And I looked around at that point in time to see if I could get another motor for it. I couldn't find anything anywhere. And eventually, a few days later, I turned it back on again, and it had obviously cooled down and started up again. But that utterly destroyed my confidence. And I never did anything else with that machine again. It just absolutely. So fast forward again to, we'd moved here, so it'd be probably 2021. Yeah, maybe. And I saw a Unimat 3 for sale on the Guild Sales and Wants. And I thought, well, it was affordable. I thought, well, I'm going to have a go at it. And this will be the sort of the make or break of my machinery career, as it were. So I bought this one. I sold that one exactly as it looks now and bought this. And that's the photograph that came with it as it was advertised. So apologies to whoever was selling it, because it's the only photograph I've got of it when I bought it. It came with a few accessories. There were a couple of chucks with it and various little bits and pieces. And I have to say that I took to it like a duck to water. Having got a manual with it, I realised about the duty cycle. So I was able to realise that, you know, you're supposed to run them for 8 minutes and cool them down for 2 minutes. In reality, you can run them for a little bit longer than that, depending on what you're doing. But once you get more confident, you don't actually tend to have the machine running that long. The reason I had it running for so long is because I didn't know what I was doing and I was just chugging away at it, you know what I mean? So because I had the manual, I was able to read the manual, I was able to work out how the belts worked and all that sort of stuff. And one of the things at the time that, and I feel like I'm going really fast here. So, you know, do sort of speak up if anybody wants to ask any questions. At the time, I sort of put it on various forums that I'd got this thing, and somebody mentioned that I really ought to get a collet chuck for it. Again, I looked all over the place in England, couldn't find one, and fellow guild member Nick Easton found one on eBay Germany, which I subsequently bought, and that's what it looked like. But it came without the pins. So I had to buy myself a metre of 8mm stainless steel bar just to be able to open and close the blessed thing. But it was just after Brexit, and I paid £115 for it. And at the time, everybody were complaining about, oh, we can't buy stuff from Europe anymore. And it was easier than buying something from over here. I got an email from Royal Mail saying we've got a parcel for you, and then next minute it arrived. There were no import duty, no nothing. So, you know, maybe I had a good experience compared to what a lot of people have had, but and I've never bought anything else from Continent since then. So there we go. The beauty about collets, and I'm going to talk about collets in a minute or two, and I apologise to anybody that knows all about them, but I've got to assume that everybody knows nothing, you know. So I'll cover whatever I can. And that was just basically what got me started. You know, I got a set of collets, which I'll show in a little while, and away I went. I got used to changing the belts for the speed. The only thing that I never got round to using properly is that it had an auto feed, but the way that the auto feed was set up, you had to twist the belt. And has yours got an auto feed on it, James? You know,
no.
for the carriage.
No.
Oh, in that case, it's the little black knob at the end, the white box that's in the photograph at the bottom left-hand side, and there's a black knob on the end of it.
Right, no, I haven't.
Yeah. Well, underneath that cover, there's another little belt, but it twists in a figure of 8. And what I found was that whenever the machine was running, this, even though you didn't have it engaged, this belt was running round, and it went through belts like no, because it were rubbing on each other, and I couldn't find a way to fasten the belt wrap. I suppose if I'd have made a new belt that was shorter, it might, you know, but I didn't know enough at the time. I've only just thought of that now. But I wore the belt out in no time. I'd never actually used it, so I never bothered adding another belt to it. So I made a lot of the stuff that in the preview video, the little globe lubricators and lots of the stuff in the early part of the video, I made on this little Univat, and it were great. And I probably wouldn't have changed it apart from, again, there was an advertisement on the Guild Sales and Wants for a Sieg lathe that was fitted with digital readouts, again at a sensible price. And I thought, I'll have a go at that. So, oh, sorry, this is just backstepping a little bit. That's what the sort of the collets look like. You'll notice there that it says 1312 for anybody that doesn't know about ER collets, and I'll explain a bit more about them a bit further down the line. This is, I know it's yet another photograph, but I just wanted to check that any standard ER25 collet nut would fit the collet chuck, and it does. So that were just an aside, because I bought that collet chuck for my mill, because at that point I'd got my mill. So just get talking about collets for a minute or two. These are all ER25 collets, and ER25 collets go from 16 millimeters down to basically less than 1 millimeter. There's umpteen different types of collets. You can get R8 collets, you can get 5C collets, but ER collets seem, from what I've read, to be the most flexible. And there are multiple different types of ER collets. You can get ER8, ER11, ER16, ER20, ER25, ER32, ER40, and ER50. And I can only assume that all the other ones have different size ranges. The smaller ones, I know the ER8 and the ER11, etc., they don't go up as big. But I'd had it recommended to get for modelling purposes ER25, so that's what I bought. And I've only sort of found out about the other ones since. They're absolutely fantastic as far as I can see. Because I've got an ER25 collet chuck for my mill, I interchange them between the lathe and the mill all the time. And I hold all my milling cutters in collets. And I've also got these, which are they're called collet blocks, or Stevenson's collet blocks, if you've been sort of given the proper name. I don't know why. Presumably somebody called Stevenson might have invented them originally. But these allow you to mill rounds into squares, put hexes on the ends of things, and I find myself using them constantly for various things. But before I had them, I used, as I'll show a bit later on, I used a pin vise with some X ends. So I've lost my flow now. I'll talk about those in a little bit. When I first started making things on the lathe, the late David Smith had posted all sorts of things on the Guild forum about things he made, and I was looking at his Unibat several times, and I noticed that he'd replaced on the tailstock. There's when you get the Unibat 3, there's two M6 cap screws, one that tightens the tailstock quill, and the other actually stops it from moving backwards and forwards, which if you're constantly picking up and putting down Allen keys, it's a bit awkward. So the first thing I did was copy David and make up some handles, and that's how they fit. So you just literally twist a handle on both of them, and away you go. But the bottom one particularly was a bit fiddly to get an Allen key in and out of. So I've not just made, sort of, and Chris hates people saying, I've not just made parts. I've also made bits to make my life easier, and various tools, which some of which I'll show people sort of towards the end of the presentation. Now we're going to something a little bit more interesting, in so much as the globe lubricators that I made in the preview video. This is the form tool that I used to make them. I've got a series of slides here to show you how I made that. First of all, I ground a flat on the top because I didn't have my mill at that time. So I just I used a file and a grinder. This is a piece of silver steel, and then I drilled a hole through it and used the pointed diamond stone, which came in a set of the things for a Dremel mini drill, and I used one of those in the lathe with the come on, brain. Sorry, I've completely forgotten what you call that. The bit that grips the tool holder. That's what I'm trying to say.
Tool post.
I gripped it. Tool post. That's it. Yeah. I gripped it in the tool post, and I ground an angle on it so it had a clearance angle. And then I used a diamond disc again from a mini drill set to grind the end to sharpen it up. The thing that I didn't do, and I didn't realize to do at that time, and if anybody replicates doing this on any kind of mill, is I really should have put some covers on the ways to stop bits of diamond dust getting on the ways, because that would damage them. Somebody pointed it out to me, and I realized afterwards, so never did it again. I've actually got some way covers on my new lathe now, but that's how I created that. And then I heated it up with a blowtorch, dropped the end of it in some oil to harden it, and then used it for turning those globe lubricators. So it's fairly simple to do, but you've just got to have the courage to do it. And bearing in mind at this point in time, I'd done very little machining, but I just thought, well, what's the worst that can happen? I'll just have a go. So then, as I mentioned earlier, we come on to, and I'm conscious that I'm going incredibly fast here. Am I going too fast for people?
No. I'm not sure whether you explained why collets are better than 3-jaw chaps. I see you've got a.
Yeah, I didn't. Yeah, you're right. Because they're much more accurate, and I just find them easier to get stuff in and out of. And
Right.
the other thing about three-jaw chucks is that they have a tendency to mark things, whereas collets don't tend to mark most things. Albeit that you might have noticed one of them had a sliver of something inside it. If I'm using brass and I'm wanting to tighten it up, I usually put a sliver of aluminium can inside it, which I'll cover again a bit later on.
Okay.
But yeah, collets recommended as being significantly more accurate in terms of run out, particularly for the small stuff that we want to use for modelling, than a three-jaw chuck, or you know, obviously a four-jaw chuck's quite accurate if you dial it in, but my four-jaw chuck doesn't close small enough for most of the stock material that I would use for making parts. It's just don't, you know, the jaws just don't close that small. I mean, sometimes I'm putting like 1 mil bar in there. So this is the lathe as I bought it from the Salem once. Over time, I've done quite a bit in the way of modifications to it, and it came with two three-jaw chucks and a four-jaw chuck, and a few other little bits and pieces. It came with a drill chuck as well, and I've added to it over time. But I probably will never buy another lathe because I think it's fantastic. I've done quite a bit of modifications to it to make the carriage a bit more rigid, and I documented those on the Guild forum. If anybody ever wants to have a look at those, the beauty about working on such things is all the carriage, the cross slide, and the compound slide, the castings for them at the time a couple of years ago, and I can't imagine they've gone up a huge amount. They were all less than £30 each, so that gave me the confidence to drill them, to put stops on so that I could lock I can now lock the carriage, I can now lock the cross slide, and I can now lock the compound slide, none of which you get as standard when you buy it. But because the castings were only like 30 quid each, I thought, well, if I wreck one, you know, it's 30 quid to replace it, which like I say, gave me the confidence to start drilling and tapping and things like that. So, you know,
what size is the metalworker lathe? What's the maximum length you can put in there?
It's the bed is 14 inches. It's what they call a 7x14. It's right. Supposedly a 7-inch swing.
Yeah.
But, I've never had anything that big in it, to be fair.
No, it's more model engineering type stuff, isn't it?
Yeah. That chuck that's on it, I think, is an 80mm chuck, but I've also got a 100mm chuck for it. But it's got rubber feet on it. It's not bolted down, and when you put the 100mm chuck on it, you can certainly see some slight movement in the on the rubber feet. It would probably benefit if I were using the 100mm chuck regularly. It would benefit from being bolted down. But I don't use it that much, or so far, because most of the stuff that I use is 16mm or less. And although I do bits of work with steel, most of it's in brass or nickel as well. So you're not putting a tremendous amount of load on anything.
Just going back to collets, Rob, another advantage of collets, if you are turning or trimming the end, shall we say, of some thin-walled tubing, if you try holding tube in a three-jaw chuck, you end up with a triangular tube.
Yeah, indeed, yeah.
As a matter of interest, what's the diameter of the spindle through the spindle on this metalworker lathe? What's the biggest bar you can get through it?
I think it's about 20mm. It's not huge. Yeah, I think it's about 20mm. Yeah. I'm pretty sure it is, because I was looking at making like a cranking handle to, for winding to for tapping.
Yeah.
Because at the minute when I'm tapping anything or running the die down it, I just sort of tend to stick the chuck key in the chuck and just wind it, you know what I mean? But I saw somebody on a YouTube video that had made a handle for the back, and I did measure it just with a view to doing that, but I ain't got around to it yet. There's lots of things that I want to do to it, but I'll get around to. I've bought a piece of cast iron to replace the compound slide, so that I can put that on and make it more rigid, and only put the compound slide on if I'm ever going to turn tapers, which I don't do that often. So any more sort of questions on this particular bit before I wander along?
A couple of comments from Steve Hother. He says that his Unimat 3 trips the electric distribution board RCD when it cuts out.
Right. Yes, mine did actually, thinking about it. Yeah.
Did it? No.
I think that's what put me off, you know, on the other one. I never managed to trip it on my Unimat 3, but on the little Unimat SL, it was because it took all the electric out when it went off. That's what sort of really put me off it.
Yeah. And,
the motors on Unimats are little more than sewing machine motors, which the fact that they trip out, you know, with continuous use, rather surprises me, because you would think that on a sewing machine that they probably get a lot of continuous use. I don't know. Perhaps it's a problem with cooling.
Yeah, I don't know. But I know Giles Farville, you know, the guy who does all the radio control stuff. He fitted motors from a sheep shearing unit, which must be quite a beast, I would imagine, onto his Unimat, because he's got two. He's got one set up as a mill and one set up as a lathe, and he got two sheep shearing motors for that, which I find quite interesting.
Dave's just pointed out that a sewing machine motor, of course, is stop start. It may have a lot. It may be used, 8 hours a day, but it ain't running for 8 hours. So
and that's the thing, isn't it? It's an 8-minute run time and a 2-minute stop. Well, I suppose as people are sewing, they'll be checking, and and presumably for people who are using sewing machines 8 hours a day, they'll be a bit more of a beast than your household motor. Like, you would think so. Yeah. Right. Well, moving on to my mill, the photograph on the left-hand side is the mill as I bought it, and the photograph on the right-hand side is the mill as it is now, with a proper milling vise. And I took the time out last October to fit digital readouts to the X-axis, Y-axis and Z-axis. The only bit that hasn't got a digital readout is the quill, which is the dial that you can see with the sort of the Sieg logo on the front. Because one of the things that sort of kept throwing me as I was using the manual dials is that the two ways, the x-axis and the y-axis, the divisions are in 0.25 of a millimeter, but yet the quill is in 0.3 of a millimeter. And it's like, like working sort of two different sort of equations out. Well, it's like, that's really hard work. Why would you not make them all the same? So I, as a birthday present from my good lady last year, I bought that, and it took a bit of fitting. And again, I've got a load of photographs. I just haven't got round to posting them on the forum yet of how I did it. And it's fantastic. It really does make milling accurately so easy. Because you've got two sort of settings on it. You've got absolute and you've got incremental, so you can zero it out on an absolute scale, and then you can switch to incremental and move it about and create more zeros without affecting your original zero, which is really quite useful. So, and I'd just like to, I don't know whether is Richard Spores on tonight. I bought this mill on the recommendation of Richard, and I'd like to thank him for that, because it's been excellent. I also got advice from Chris Simpson at the time that I was looking for one, and I'd also like to thank him for his dialogue on it as well. So hopefully I'm embarrassed you too, but thank you. So this is the other bit of kit that I use regularly in the shop. Although I've got a drill chuck for my milling machine, and I use the milling machine for drilling bigger stuff. When I'm doing really small, you know, the sub 1 millimeter stuff, I use my Proxon mini drill because I just lift it into position, put it on, and those that have got sort of eagle-eyed memories will note that it's now got the Unimat chuck on it that was sat on the Unimat I sell when I bought it. Sorry, the Unimat Vice, should I say, not chuck.
Just going back a moment to the milling machine. Phil Stone was saying, can you tell me what make this mill is and approximately what it cost?
It's a Sieg SX1 LP, and the LP stands for long long table.
Can you spell that, please?
SX.
Hang on a minute. Wait a minute. I'm just going to put it on the chat to everyone.
Yeah.
I just can't find everyone. Where's everyone gone? Oh, I don't know. No, it's not working. What's going on? Oh, there you go. Right.
Yeah, it's an SX1.
SX1.
Which presumably stands for Sieg X1 LP.
Right. LP.
Yeah, and the LP stands for basically it's got a longer table in the X direction, you know, the side to side, than the front to back.
Okay.
And it was, I think, £650 when I bought it.
Okay.
And I've spent another probably 350 on the digital readout.
Right.
Oh no, maybe not quite that much actually, thinking about it. Yeah, probably about 300.
So it's quite an investment, isn't it? £1,000 altogether.
Yeah, it is. You can occasionally get sort of deals, but at the time, this was when I bought it, it was sort of just as COVID was coming to an end, and Chris Simpson had recommended the Chester equivalent, and I'd had a look at the Proxon and one by Amadil, which I can't remember the name of. I created a spreadsheet with all specifications, and although this one actually came out top in my mind in it, it was actually the only one that was available to buy, because all the rest of them, you know, nobody had any stock of them, so it was Hobson's choice anyway.
Right.
Yeah, but yeah, I've been really pleased with it, and I wouldn't hesitate to buy another one, which is, you know, sort of all the recommendation you can give, really, isn't it? Yeah, the rotary table that I've got on the side of it, it's sat there, and I think I've only ever used it the once, but I will get round to using it at some point. Right, going back to the Proxon mini drill, on the side there's a dividing head, and I use that all the time, and I use it for things like you know, like drilling out bolt holes for buffers and things like that. And I think I've got a photograph of it a bit later on. Even though, as I say, even though I've got the mill and it drills very accurately and everything else, I wouldn't be without that. It's really, it lives on the corner of my bench, and I just literally lift it onto the bit where I work, plug it in, do my drilling, put it back out that way. Yeah, it's brilliant. And you don't get a coordinate table with it. I bought that as an extra, and I think the coordinate tables are about 100 quid with the X and Y axis on it, and the dividing head was another 100 quid. So again, there's probably 350, 400 quid in that altogether. And a reasonable quality vice is probably about 50 quid as well, because they're ridiculous price for stuff now, aren't they? But again, a good investment. And you can get a mini mill, a mini Proxon mill, which I looked at, but everything that I read online said that they run at too fast a speed for most things that we do modelling wise. So which was another reason why, and I didn't really think it had enough grunt for what I wanted to do, because I wanted to do things beyond 7 mil modelling. I've got a stationary steam engine to build at some time, just a small one, a vertical stationary steam engine. So I wanted something with just a little bit more grunt. But yeah, it's pretty good. And these are some of the things that I use it for. And I mentioned in the preview video, the hardest thing with milling, drilling, and using the lathe is working out how best to hold things. And over time, I've come up with all sorts of weird and wonderful ways to hold odd-shaped things. That's drilling through brake shoe castings, which of course there's nothing flat on a brake shoe casting, is there?
Right.
You know what I mean? So what I did, I've got this old pair of pliers that I've used for soldering, and I've filed the ends down that many times because they've sort of corroded away. And I took the spring off it so that it didn't keep opening, and just grip the bottom of it in the vice jaws, and then just pop the casting in. And because it's got the XY coordinate, you can move it backwards and forwards to center it, and then just drill away. You know, dead simple. Yeah, holding things is this sort of section of what I'm talking about. Well, it's all about holding things. So I'll just go on to the next one. Right. That's the coordinate table in sorry, the dividing head in action. This particular one is really easy to use. It's got quite a visible dial on it, and you just slacken it off and wind it round by hand. Whereas the rotary table for the mill, you've got a little handle, and I think it does something like 5 revolutions of the handle to get it to go around the table, sort of a quarter of a turn. You know, it's a fairly tedious job if you're going a long way around with it, which is why I tend to use this for a lot of my modelling stuff. Again, something that despite it being £100, I've never regretted buying it. As you can tell, I'm a bit of a tool junkie. Again, holding things. This is the smoke box ring for the Princess that I'm building at the minute. And you'll notice, again, a strip of aluminium can around the jaws to stop the jaws marking the inside of the smoke box ring. But once I'd got it all on and centered, it cleaned up and turned absolutely perfectly. It just took a bit of figuring out how best to hold it, which again is half the battle whenever you're machining anything. Is all the thinking time goes into, well, how am I going to hold it so that it doesn't sort of fly off into space or hit me in the face or whatever. I mentioned earlier, before I got the collet blocks, I used this. The 2 shiny shadows at the back there is a machinist clamp so that it goes back in exactly the same place. And then I just use the 2 flats on the pin vise as the indexing, and just mill a flat, turn it over, mill a flat, turn it over, mill a flat. And I usually just put a marker pen mark on one of them so that I know how far round I've got. But anybody that doesn't have a collet block or they're wanting to use something really small, you could do that. I should imagine that if you were doing something really light, like sort of small brass bar, and you had a milling cutter, you could probably get away with using the Proxon mini drill to do something like that, because there's no real load. As long as you've got a sharp cutter. The other thing that I do use, and I haven't got any photographs of it on here, is for come on, brain. the mini drills you get in these multi-packs, you get burrs, and you get like ball burrs, and you get sort of flat bottom burrs. I've also used burrs to mill slots. Admittedly, I've used them in milling machine, but again, if you were doing something really soft like aluminium or brass, there'd be no reason why you couldn't do it in a pillar drill with a coordinate table, as long as you took it steady and you didn't go ridiculously heavy cuts. If I'm making nuts from small tube, I just use that and a file, and I just file a flat, turn it over, file a flat, turn it over, file a flat. Just make sure that you've got a file with a safe side so that you don't wear your little collet away.
Were those collet blocks a commercial item, Rob, or did you make them?
No, the collet blocks are commercial items. You can buy them either on eBay, or I think I got mine from Mark Euro.
Yeah.
There's lots of sort of machinery suppliers, but you just need to make sure that you buy ones that suit your collets, because as I said, there's umpteen different types of collet. The other thing that's really bizarre with them is that you don't get a collet nut with them. So if you buy the collet blocks, you buy them individually or usually in pairs, but then you have to buy a collet nut to go with them, which seems really bizarre to me. I mean, obviously you could buy two, but you're never going to use them both at once, so I've only ever bought the one nut. So between my lathe and the mill and the collet block, I've got 3 collet nuts, and I'm never likely to use all 3 of them at once and need a fourth, I don't think. So I've never got around to buying a fourth. These are the drilling the springs for the Princess for the tender, and I decided that to take the white metal spring damper pieces off and replace them with some nickel rod. So I wanted to be able to grip the castings without damaging them. So I split a close peg down and used a close peg. Another really good thing that worth investing in is a set of parallels, which are the metal bits in the bottom of the vise there. They're absolutely invaluable. The only thing is that they only go down to a certain size. So what I've done for doing really thin parts is, when I bought, can't remember what I bought, but I bought from one of the machinery suppliers a piece of tooling of some sort, and they sent me some really cheap and nasty steel rules. I'm talking about the probably 0.8 of a millimeter thick, you know what I mean? So what I've done is I've actually snipped them down into 4-inch lengths, and I use those as really thin parallels. You know, if whatever it is not suitable to fit on the thicker steel parallels that I've got. I also make use of, I mentioned superglue collets in the video. I also make use of solder, and as you can see on the right, I needed to make some brass split pins to hold the vacuum ejector pipe on the Princess. So I soldered some. I've got 44 meters of 1.5 millimeter rod, because I inherited a pack of brass brazing rods, which are all 1.5 mil thick. And as I say, I've got 44 meters of it. So I thought, well, let's go out and buy some. Why don't I just make some? So I just soldered some lengths of 1.5 mil rod to that piece of brass, and then just milled it down to create the halves and annealed them and bent them over. You'll also notice that I've got some springs in the vise. I gather springs from all sorts of different places because they're brilliant for keeping parallels apart. And if you can't get a spring in, if it's too narrow, what's really good is, you know, pieces of foam rubber that you get in packaging. If you just slip a piece of foam rubber in between your parallels, it just stops them sliding out the side or moving together. And it doesn't really matter too much if you drill through into it. Any questions so far? No. We're on to jigs now. When I was doing the tender brakes on the Princess, I was struggling to get them to fit without them shorting. So I designed and had 3D printed some brake shoes, and then I decided, well, I'll machine the sides of the shoes off so that I could fit the 3D printed ones. So I started off with a piece of brass with a hole in it to hold it to machine one side, and then I modified it again to, I forgot, yeah, that's it. I modified it again like that so that I could fit the other side in, and ultimately I was able to chop all the bits off, and those are the brake shoes soldered on at the end. So and I'm pretty sure that that piece of brass is a plug pin. Whenever we're throwing appliances out, I always remove the plugs and destroy them and take the pins out. Because they're very useful bits of brass in them, and I've made lamp irons from them and little jigs. I mean, they're not huge pieces of brass, but they make quite useful little bits and pieces. So yeah, I never throw anything away. And again, this is another plug pin that you can see the shape on the end. I needed to make some forked ends on some of the rods. So I decided to make myself a little jig that I could use to make forked ends over and over and over. So what you do is you put your piece of that you want to bend into a fork onto the top piece. You see there's a little piece of piano wire there that locates through the hole to hold it in place so that it's exactly where you want it to be. And then you put the other piece on, slide it on resting on the bottom side, slide it up to the little angle piece, and then squeeze it together in a vise. And it just makes forming forked ends on rods so repeatable out of just a couple of tiny little bits of brass. It's quite incredible, and that's it in action. The angle bit I cut with a countersink bit. I milled it across square, and then I just ran a countersink bit across it just to to create the angle, which gave me a 60-degree angle. But as you can see, how with the 5p piece there, how small the forks are, but they work perfectly.
What would these be for, Rob? For reversing rods and things like that?
I think that's the reversing rod. Yeah. But I also did some for some of the valve gear. Because a lot of valve gear that you get, it's only one dimensional, isn't it? If you're lucky, you get two pieces that you can solder together and fork out, but quite often a lot of them are just a single rod. And when you're not putting as much effort in, you want it to look as good as you can, don't you? People may remember in the video that I did, I showed that I'd machined the chimney for the Princess. When I fitted it on, the chimney was 3D printed by Mike Hopkins, and he did it from the drawing in the Wild Swan book, which has the insert piece that sits down inside the smoke box. But what Mike had done is he'd put all his supports on the bottom on the basis that that's the bit that's not likely to be seen, which makes perfect sense. But the trouble is actually cleaning them up and getting it to sit right on the smoke box was really difficult. And I'd soldered it on, and it were only up a tiny little bit, but when you start taking close-up photographs, I had somebody comment saying, you know, tongue in cheek, but it resonated. When you're going to sit that chimney down properly. So I've thought about it for quite some time, thinking, well, how on earth am I going to hold it? Because again, this is the whole issue. So what I did ultimately, I got a piece of aluminium bar and I turned it down to be a tight fit in the chimney, so tight that I had to actually tap it on. And then I used a fly cutter to cut the piece that sat down underneath the chimney. The problem that I had with it was making sure that you know, that it was absolutely vertical, so that when I got to actually cutting the base of the chimney, that I was cutting it in the right orientation. So what I did was I made a cut, took it out, checked it, twisted it a little bit, made another cut while I was still cutting the you know, the protruding bit. I don't know what you call it, to be honest, the bit that fits down inside the smoke box. But I gradually sort of, oh, is that the petticoat? Yeah, yeah. So I gradually got down to that, and then I thought, right, well, now I've just removed the bit that actually helps me centre it on the chimney. So I thought, probably I can reuse the spigot. So what I did was I machined the spigot so that the chimney would sit on it as it does in the right-hand side there. I chopped it off because made it a bit shorter. The groove that was there was just something that was already on the piece of bar from, I can't remember what I was using it for previously. And then what I did was I put that sort of former spigot inside the smoke box, and you can see the Heath Robinson way that I put it together there with a couple of bits of wood, a couple of bits of lolly stick and a metal block, enough to push it up. But then I could sit the chimney on it, and it held it completely central, and I just ran round it with my blowtorch, and there was enough solder already on the top of the smoke box from where the chimney had been sat there previously, and it just ran round and soldered it on perfectly. So I've kept the spigot, but of course the next time I want to do something similar, it won't be the right size, of course. So but I'll certainly use that method again. You've just got to sort of think about it, you know, as I say, holding it's the name of the game. It's that holding it secure is everything. And I keep mentioning about drinks cans and things. You may have noticed way back on the slide where I showed the two pictures of the mill. At the side of the mill there were three tall containers. Those three tall containers are shaving foam cans. For my sins, I'm a wet shaver, and or rather my good lady buys Nivea shaving foam. So when I've emptied the cans, I chop the ends off them and reuse them for all sorts of things. Some of which is the cider can there is, I use that for wrapping around things in the chuck or in the vice or what have you. The little strips that you see there, I use them as the 0.1 millimeter thick, and I use them as feeler gauges when I'm bringing the milling cutter down so that I don't knock the edges off. I put a strip of aluminium can in between it, bring it down to the workpiece to zero it, and I know that it's exactly 0.1 millimeter above my workpiece once I've dropped it onto that piece of tin can. But it does, obviously, it protects the milling cutter. The Nivea cans, it's a bit thicker material, and you'll see the sheet at the bottom. A few days ago, I thought I wanted something to make a van roof from. And I thought, I wonder if I can just run it through my rolling bars and flatten it out. And sure enough, you can. So that sheet there is basically an unrolled Nivea shaving foam can with both ends chopped off and cut down one side. and it makes quite a decent sheet. I don't know how thick it is actually without going and measuring one, but it's certainly significantly thicker than the cider cans or Coca-Cola cans or what have you. You will notice it says alcohol free there. Yeah. So yeah, stuff like that. And another thing that I do, and I haven't got a slide on it, but I'll mention it, is soap dispensers, pump soap dispensers. When you empty them, they've all got, or nearly all got, a stainless steel spring in them. So I take them apart and take the stainless steel spring out of them, and I've used them for all sorts of things. So I'm always looking at recycling. So moving on. Now I've got to the bit where I was asked if I'd show some of the tools that I've made. The wheels for the Princess came with the crank pins pre-drilled for 8BA, which is significantly bigger than I normally replace Slater's 12BA crank pins with a 10BA, which you can just then tap out their crank pin bushes quite easily, and you can put slots in them, and the Romford spanner at the bottom there fits perfectly. But because I didn't have anything big enough, I decided to make my own equivalent of a Romford spanner, which is a piece of 5mm silver steel. I think it might be 3/16 actually. I drilled a hole down the end of it so that it went over the end of the crank pin, and then just milled points on the side. And I thought, well, I'll put a nice little handle on it, and that's one of the tools that I've made. And it's an absolute joy to hold. You've made it yourself, and every time I use it, I think brilliant. But to be fair, I am going to let it go with the Princess, because the chap who I'm building it for, if he's not got anything to take his wheel off, that's not going to be much fun, is it? So I may make another one at some point if I ever need one. Another tool that I had to make as part of the Princess build is when I was fitting the steam pipes from the cylinders to the smoke box, they were too short, and I made some collars to go over the ends of them, but then I needed to remove the cast white metal collar from a pin. So what I did was I again drilled a hole in the end of a piece of steel, and setting it at an angle in my collet block, I milled across and just kept rotating it round until I created 4 teeth on it. I then gripped the other end in a pin vise, slid that over the spigot on the end of the steam pipe, white metal casting, and just gradually just wound it round, and it just pared away the collar on the steam pipe while leaving the inner bit perfect. And then I could slip the nickel silver collars over the top that I've turned, and job's a good one. So, and the piece of steel is something that I recycled out of a fuser unit for a printer. The fuser had gone, so we got a replacement fuser. So I thought, well, I wonder what's inside here then. So I took it out, rescued a load more springs, and I got that steel rod out of it. And it's some of the nicest machining steel that I've ever used. Absolutely machines brilliantly. So again, if you throw in printer bits and pieces away, I've also taken the drive roller out of toner cartridges and cut the rubber drive roller off and kept the steel pins out of there. I don't throw anything away that's usable. And then
in the good old days of manual typewriters, Rob, they were a very, very useful source of springs. They contained thousands of identical length springs.
Yeah, I can imagine. Yeah,
if you ever got hold of an old typewriter and dismantled it, you've got springs for life. Actually,
yeah. It's not something you see these days, though, is it? And if you did see one, people, they wouldn't want to take them apart, would they? Because they'd want them for museum pieces and things. Yeah, yeah. These are tap spinners, and I got the idea from there's a guy on YouTube, and I would recommend anybody interested in machining, I would recommend go on YouTube and look for Joe Pye. And his name's Joe Piezinski, but his username is Joe Pye. And he's actually from New Jersey, but he's got a machine shop in Texas. And while he's got a great big lathe and a great big Bridgeport milling machine, he's such a good shop teacher, and he has so many useful tips. And this is one of his tips was, when you're using really small taps, if you use a full-size tap bridge, the chances of breaking them is fairly high. So he just came up with the idea of get a bit of aluminium bar. The one on the left, the aluminium one, is actually off that piece that I use for the support spigot for turning the chimney. It's off the other end of that. And literally all you do is you pop it in, and then you can really feel the tap as it's working. And if you start to get too tight, because I've put it on the round bit of the tap, it actually starts to spin before breaking your tap. And they're brilliant. I had a little offcut of nickel bar left, so I thought, oh, well, I'll make a posh one, and made one out of nickel as well. That takes slightly bigger taps. But I've made a few of the aluminium ones for friends and just handing them around. But particularly if you're using a tap follower in the lathe or the mill, it's really, really useful for tapping fine things without. I've only ever snapped one tap in my life, and it cost me almost as much as my box of taps I bought in 2010, I think. No, it'd be before that. Probably 2008, maybe. I bought a box of BA taps from 0 to 10 BA, and I paid £30 for it. And I think to replace one broken 8 BA tap, it cost me about 12 quid. So shows you how things have gone up in the meantime. This was probably about 18 months ago. So again, another Joe Piezinski job. This is a very, very small tap wrench. As you can see, it's only 60 millimeters long. It's tiny, but again, just for slightly bigger taps and just very, very tactile to use. And that's made out of the same piece of stainless steel that I bought for the 2 bars for tightening up the collet chuck. So I'm getting my money's worth out of it. I bought a meter of it, and I've still probably got about half a meter left. I just keep using little bits of it. And one of the things that we all use, but they can be quite lethal in a workshop if you're not careful with them, is a scriber. And I originally made this with that was just smooth. I didn't put the hexagon end on, and I found that it kept rolling off the bench. So I thought, all right, well, I'll modify it, and I just made a little hex end. And to stop myself, so I could keep it in my pocket and stop stabbing myself, I made a cover for the blade. And it just very quickly screws on, screws off. And I use that almost on a daily basis. So a nice little project for anybody with a lathe, just to get themselves into doing it without, you could put a piece of square bar on the end. It doesn't have to be a hex. I just happen to, I've got a collet block, so well, why not? And you don't necessarily have to put all the little grooves in it or anything. I was just, playing about, seeing what I could do. But yeah, another nice little tool. It's really nice when you're using tools that you've made yourself. It just gives you so much satisfaction.
If you haven't already done so, Rob, could you post some of these pictures of these gadgets on the forum?
Most of them I have in the, there's a hints and tips section.
Okay, yeah.
Most of them are in there somewhere, Dave.
Right.
But I will have a look and make sure that I have included everything. This is a depth gauge. I've got a really nice Moore and Wright metric depth gauge, but the problem is the pins are probably 5 millimeters thick. So they're only any good for poking down quite big holes. Well, obviously we do quite small holes. So I had a piece of scrap left. This when I did the modifications to the carriage on the lathe, I'd cut a piece of steel, and my slitting saw had wandered off. So one of the edges of the bits where there's a slope on the far side was all chavelled up by the slitting saw. So I just thought, oh, well, I'll just mill those off at an angle to tidy it up. And when the first time that I drilled it, the drill managed to wander. So I popped the pin through it, and it came out at an angle. And it was only a slight angle, but it just enough to absolutely annoy you. So what I did was I got a milling cutter, and I ran a milling cutter through the hole to straighten the hole up. And then I put a nickel silver bush inside it, so that, and where the bush is in the middle, where the little screw knob is, I milled a slot in it so that you could tighten the thumb screw down. And now it fits properly, squarely, and doesn't annoy me every time I pick it up. Because it was only out ever so slightly, and I'm sure that most people wouldn't have noticed it, but it absolutely bugged the devil out of me every time I picked it up. So I couldn't resist straightening it up. These are a couple more bits and pieces that I made. The bit on the left is a vice stop for the vice on my mill. You may recall me mentioning sort of early on when I first got it, I was using engineer's clamps, and I've got a little brass hand vice, and I've also used that as a vice stop in the past. But again, I saw something on one of the YouTube videos where people have made little vice stops, and I thought, oh, I've got some little blocks of steel, I'll have a go at one of those. And I made the Allen key out of an old bent Allen key and some really cheap punches. They were that cheap that drilling it out to actually fit the Allen key in were the easiest thing in the world. I'm not sure what they're made of, but I think it's one step up from butter, but it works perfectly. So, again, I don't like throwing anything away that if I can reuse it. That Allen key also fits the two slide stops on the mill that stop the carriage, the tables going either way. So that's in use quite a lot, is that particular Allen key. And other things that I've done to make life easy is make some comfort handles. I don't know about you, but what I find particularly with drill chucks is when you get just like a bar, they're really uncomfortable to you, particularly if you're sort of tightening them up and slackening them regularly. So I just got some bits of Delrin. I had the thick white stuff, and I bought the black for making some bushes for somebody, and I'd got some short pieces left. So I just turned some little comfort handles, again, something that I found online that somebody had done. And they make them so much easier to use. Really simple to do. Just to improve your life, the work of moments, just to turn a little taper on and drill a hole. And one thing that is worth mentioning is if you're going to do them and drill them and stick them in with Loctite, is to drill a small hole right through the end so that the air comes out when you push them on. Otherwise, you'll push them so far and they just stop, which is really quite frustrating. Then the little gadget on the left, again, this was something that David Delos, posted on one of his many postings on the forum, and it's a cut burr for when you get lengths of wire and you snip it and you want to take the burr off the end and round it over. You can buy them from Cooks and Gold in all different sizes, and I bought a couple of sizes on the recommendation of David. but they just come with a little pin. And for long enough, I was faffing about using them in a pin vise. And once I'd done that, I thought, well, I've got another little bit of plastic. I'll just make myself a little comfort handle. And again, it's a joy to use now. So really simple, and dead easy.
Got a question from Phil. How did you hold a slitting saw on the Unimat? He's asking.
I didn't. I did it in the milling machine.
Ah.
Yeah. It was when I'd already let the Unimat go by then. It was when I was upgrading the carriage. I fitted a carriage stop to the Sieg, and I also fitted carriage stop and like an end piece that just strengthens the whole carriage. Something else that I'd sort of found on YouTube, and a former member who I can't remember his name now, had also done it. So I just basically copied what they'd done. There's, if you just type lathes in or milling machines into YouTube, there are 1,000,001 videos, some of which are quite tedious, but there are loads of hints and tips that you can pick up for beginners. I can't recommend YouTube enough for people. It's fantastic. I did it in the milling machine. I think what it is, I bought a proprietary slitting saw that with an MT2 shank on it, and it's designed to fit lots of different sizes of slitting saw. And I think I'd have been better getting one that just fitted one size and fitted it properly, because it just doesn't run true. And I'm considering putting it in the lathe, because I've now got a sleeve that'll take MT2, and actually turning the end of it so that it'll accept the slitting saws accurately. But it's just that's on a future project, as it were. So I'll just move on. Another thing that I did, the little thing in the middle is a markets nut spinner. And when you buy it, you get the bar that's marked markets, and you get all these other different ends with it. And you're forever screwing them on and off, which is a pain in the neck. So I thought, oh, well, I'll make a few other handles for it. And I made the 8 and 10 BA, which the 12, 10 and 8 are what I use pretty much all the time. So I only had one piece of bar left, so I thought, well, I'll double end it and put the 16 and 14 BA that I don't use that often onto that. And again, really good to use. I put the hex ends on so that I had something to grip to tighten them with, but hopefully I'll never take them back off again. I must say that, again, another tool that I can't recommend enough, although I have posted on the Guild forum that, again, on the advice of David Smith, I routed through my socket head screw box, and I found some cap screws that fit. I think I've got 10 BA, 12 BA, and 14 BA and 8 BA on some, that are just, all they are is cap screws on some screwed in the end of a thin piece of bar and Loctited in. And it's quite remarkable how good they are as well. So you can do it for virtually nothing. I mean, I think when I bought this particular set with just the one handle, it was about 18 or 20 quid. I think they're nearly £30 now, but they are very good. And again, because they're the sizes that we use all the time, they're in almost daily use on my bench. And I think this is finally, for those people who didn't see my video that I did for the last virtual show, I made a gearbox on the milling machine, and this is it, and it works absolutely perfectly. And I did a video of how I made it on the for the virtual show last year. I appreciate not everybody looks at such things, so I just thought, well, I'd include it at the end, as it were. I've no idea what time it is.
It is currently 20 past 9.
All right, so we've actually
If
about perfect time then, because I had no idea how long it was going to take. So yeah, you're only limited by your imagination, and obviously the most important thing is holding things safely, which I hope I've sort of hammered home to everybody, as it were, in the nicest possible way. So yeah, that's me. I'll stop sharing my screen. Anybody got any more questions? I'm more than willing to. I'll stop share, Phil. More than willing to answer them. As best I am.
Well,
As I say, I'm not an engineer.
comment rather than a question. Rob, I mean, I am a trained engineer. I served an apprenticeship in engineering.
Right. Sorry,
And then
who am I speaking to?
My host, Dave.
Oh, sorry, Dave. My apologies. I couldn't see that you're talking. Right, yeah. You're a trained engineer, or you've been.
Yeah, I served an apprenticeship straight from school, for a 5-year apprenticeship, and then stayed on for a couple of years. And then I left the engineering trade for 27 years, and then went back into it when I bought a tool making business, which I ran for 20 years.
Yeah.
And I totally agree with what you say about making jigs and fixtures and gadgets, because all these things make life so much easier when you're doing, particularly if you're doing a lot of repetitive work. I mean, I make jigs for everything. If I've got to make more than two of anything, I'll make a drill jig, for example, or some sort of holding fixture.
Yeah.
Jigs are invaluable.
Yeah, I agree. Yeah. And they're fun to make as well. And they increase your skills. I mean, I've learned absolutely everything essentially since 2021 when I bought my first lathe. Yes, I had a grounding in it when I did my O level, but how much do you remember 38 years later? You remember what you've done, but actually how you did it. The only thing I could remember from school actually was taper turning. Funnily enough, I remembered how to do that, but everything else, and I'd never used a milling machine before. But I went out and looked online, and as I say, there are some absolutely two people who I'd absolutely recommend anybody who wants to get into machining have a look at is Joe Pye, and there's a chap called Clickspring who's an Australian clockmaker, and he's got loads of really short videos that are really good tips, and he uses small lathes, so much more suited to what we do. To be fair to him, he's got a furnace and he hardens stuff and does lots of things that, I've not got any equipment to do. But his actual turning and things like that, and some of the stuff that he does for making clocks, it's absolutely fantastic and well worth some of your time to watch, it really is. Well, thank you very much to everybody, and hopefully it's been of some enjoyment and some use and some interest.
Yeah, we have one.
Hopefully, I haven't bored you stupid.
We have one further question. Where'd you get your materials from?
Generally via eBay, because the trouble with a lot of there's a company called Noggin End Metals that I had recommended, and the prices of the metal are actually quite reasonable. The postage prices are outrageous. Whereas, if you look around on eBay, you can buy. There's a company that I use a lot of nickel silver, and the reason I use a lot of nickel silver is there's a company on eBay that I think is called Howarths, and they're a musical instrument making company. And I've no idea what they use nickel silver for, but they use nickel silver, and you can get it from anything from 5mm up to about 30mm, but they're all in short lengths, which are the sorts of things that we use. And they're really reasonably priced for these short lengths. If anybody wants the link to it, I'll send them a link to it, because I've bought tons of it. I've got quite a stock of it. But yeah, I just put in a search in eBay. purely because it's convenient. I mean, I live in the middle of nowhere. It's not like we have a steel stockholders that in Thirsk, which is probably about 20 miles away. And I thought, oh, brilliant, steel stockholder. But they sell everything in 6 meter lengths. So can I mean, I bought a meter of 8mm stainless steel 3 years ago, and I'm still using it. You know what I mean? So you're never going to use 6 meter lengths as to fire. Well, Dave might have done in his business. I'm sure he was using tons of it. But I mean, I buy stuff from Metalsmith at shows and what have you. But Barry doesn't stock all the different sizes that I want. So I get it where I can. And as I say, I'm a great one for recycling out of anything that I'm chucking away. I have a good look inside it before I throw it in bin. My missus laughs, but we always use springs and bits of metal and stuff like that. So yeah, everything you're going to throw away, just have a look at it and think, well, what can I make from that before I throw it away? You can tell them the auction.
Unless there are any more questions, I propose a vote of thanks to Rob on behalf of everybody for a very enlightening and entertaining session. I think James has got some slides to show in a moment about the guild. This is for the benefit of any non-members who are watching this evening. But anyway, from everybody, Rob, thanks very much for a very interesting session.
Yeah, thank you, Rob.
Hopefully somebody's got something out of it. And if anybody has got any further questions, you can contact me through the forum, or my email address is registered with the guild under the members section. So feel free to drop me an email. As I say, I'm not an engineer, I'm not an expert, but I'll certainly give you my enthusiastic amateur's take on it.
That's great, thank you. Right, what I'm going to do now is to share this PowerPoint presentation. Right, so our next presentation for an evening with will be Peter Reynolds discussing how to use DCC. And now I bet this isn't going to work. Oh yes, it is. And this is the calendar for the rest of 2024. So we got Peter Reynolds on 26th of May, and then in June, Remy Lord talking about his model of Selby, including the swing bridge. And then Ian Allen talking about CAD to casting, how to use 3D CAD to design your components, get them 3D printed, and then turn them into a casting. August, now this is interesting, August is 27th of August, not the 26th. Must be a reason for that. I think the 26th is a bank holiday, probably why. Philip Downs talking about radio control, and then September, John Neeshaw and Jay Best, Julian Best, yes, train control systems. October, Dan Everson, painting and weathering figures. And then for our non-members who are watching tonight, we can offer membership of the guild. Oops, sorry. Membership of the guild. There's you can join online. You can also do a free month of membership, so you can trial things out. When you do join, you'll then enjoy quarterly gazettes, etc. And then our website covers an awful lot of information with our knowledge base now, our wiki, just like Wikipedia, but specifically for O-Gauge. And then sales and wants, etc., etc. So if you want to join, you can go through the website, go to About Us, and there's apply to join as one of the options on that menu. Okay, join online. And then the other thing we have, of course, is our YouTube where we host lots and lots of videos, informative videos, plus layouts, etc. These are our shows for this year, 2024. We have our summer show coming up on the 1st of June at Kempton Park Racecourse. Our big 2-day event at Guildex in September at the Stafford Showground. And then the winter show, the new winter show, which is in Wigan this year in December. So please come to those if you can. Okay. And that's the end of that presentation. Whoop, just close that. Right, Dave, over to you.
Well, I think we've just about covered everything. Thanks for your help, James. I'm just looking to see whether there's anybody here who. Oh, a few have dropped off the the viewing panel by now. But anyway, well, all it remains for me to do, for those of you that are still with us, is to well, thank you for coming along, and hope you enjoyed and learnt a bit from Rob. As I just said, although I've been in the engineering trade, if you like, on and off for, well, 60 years. You still, when you get talking to other engineers, model engineers, there's always something to learn. And you know, you come away thinking, oh yeah, why didn't I think of that? You know, all these little hints and tips it's all useful stuff. So thanks again, Rob, for
Yeah,
that.
no problem.
And
just have a go.
Yeah. And I think with that, we'll say good night to everybody.
Yeah. Good night, all.
Good night, all.
We'll see you at the next one.